Antimatter. That word probably makes you think of Star Trek or Doctor Who or something else like that. But far from being science fiction, antimatter is science fact, and it's one of the most interesting substances in the universe. In fact, its behavior is one of the biggest mysteries that we have in fundamental physics today. And I work on an experiment at CERN's Large Hadron Collider, which is devoted to trying to understand this elusive stuff in more detail. So why is it so important? Well, the deal is that we understand that everything in the universe is made of fundamental particles, matter, and we know that every type of fundamental particle has an antimatter counterpart that behaves as a mirror image, oppositely charged version. The interesting thing about antimatter is that when it meets normal matter, it annihilates, releasing enormous amounts of energy. So if I have 1/4 of a gram of antimatter meeting 1/4 of a gram of normal matter, the resulting annihilation has the explosive force of 5 kilotons of TNT. Now that's something you'd notice, but it doesn't seem to be happening around us on Earth, and it doesn't seem to be happening out in space anywhere where we've been able to look. And that is the mystery. That's really strange, because we think that when the universe started in the Big Bang, half of it was made of antimatter. And just after the Big Bang, the fundamental particles that compose the universe met, and the antimatter and matter versions annihilated each other, and these annihilations created photons of light that then could split into new pairs of matter and antimatter particles. And this whole process of annihilation continued as the universe expanded and cooled down, until eventually, a few seconds after the Big Bang, the universe had cooled so much as it had expanded that there was no longer enough energy left in these annihilations from the antimatter-matter collisions to make new pairs of matter and antimatter. And the whole process of annihilation stopped at that time. And what remains in the universe now, what builds stars and galaxies and us, is a consequence of a very tiny difference between the amount of matter and antimatter that must have existed at that point. But the fact that there was that difference is so significant because it tipped the universe in favor of matter and let us exist today. And it's for that reason that we really need to understand antimatter. It's still one of the biggest unsolved mysteries in fundamental physics. And that's why our experiments are eagerly taking data to try and find the difference from the LHC collisions. We have no underlying explanation for why antimatter should be different. We almost had no expectation that antimatter should exist, and that only that equation that predicted it, well, that's our only theoretical input, and that predicts matter and antimatter should be the same.